Welcome to the Math Record. For Chapter 2, I'll be exploring several applications of the derivative. The majority of the derivative applications are going to deal with understanding graphs. So these includes maximum and minimums, which is going to cover this video, increasing and decreasing intervals, which I'll cover in the next video, inflection and concavity, which I'll cover afterwards, and then a few theorems, which I'll cover in the end. So how do we find maximum and minimums? Well, all we have to do is understand parabolas. And the reason is because if we just kind of draw a random graph, you'll understand why. So all we have, maximum and minimums, which are points like here, 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 and here, these are just made out of parabolas. So there's a parabola right here, there's a parabola up here, parabola, and a parabola, right? So it's just made out of 4 different parabolas. And that's basically it, or a little bit smaller if it's to get more precise. But basically, it's just made by parabolas. So if you understand how parabolas work, so we have a parabola going up, I want to make it a bit wider, and a parabola going down. So if we have a parabola that's going up, then this is obviously a minimum. And a parabola that's going down, this is obviously a maximum. So how do we determine if these are actually maximums or minimum? Well, there's actually a really cool thing with derivatives. The derivatives at minimums or maximums are 0. Okay, so something like this. And the reason is because if you kind of think about it, let's just choose 2 points here and 2 points here. And you could do the same thing for maximum, but I'm just going to do it here. So if we go do the derivative here, that's negative. Now we do a derivative here, that's less negative. So as we choose points that goes down, it gets less negative each time. So then once we reach to our minimum, it's going to have a derivative of 0. And it's the same logic as when we're working from this side. This has a positive slope. This is a positive slope for this point also, but it's less positive. So as you go down this point, let's say we choose another point here, this gets even less positive. So once we get to our minimum, we get a derivative of 0. And in both cases, for the minimum and maximum, the derivative here is going to be 0, which makes sense because you're just drawing tangent line to a point there, and it's only one point, and so it's going to be that 0. So how do we determine which one is a minimum and which one a maximum? Because both of them have a derivative of 0. Well, all we have to do is check which is positive and which one's negative on either side. So let's choose 2 points here. Now, if we do a derivative on a point here, that's negative. So on this side is negative. And if we do a derivative on this side, that is positive. So a minimum goes from negative to 0, right? From negative to 0 to positive. Now, if we go for maximum, we have a derivative of that's going up, so that's positive. So that's a positive derivative. Now the derivative of 0, and then if we choose a point here, that's negative, because that's going down. So it's positive to 0 to negative. And this has a really special case. This is actually something called the first derivative test. Okay, so let's delete this. Actually, I'm just going to delete this. So then we can save this row because it's easier to understand. So the first derivative test, which basically states that if we're given a function f of x and we have and we find its derivative and we set it to equal to 0 or undefined, I'll explain why that later. Then if it goes from negative to positive, right, negative to positive, and since we set it to 0 as 0 or defined, which I'll explain later as I said earlier, then this is going to become a minimum. Now we go from positive to negative, and we have a derivative that gives us 0 or undefined. Then basically we have a maximum. Okay, so let's explain why it could be undefined. And the reason comes back to a parabola. And the reason is because it's actually going to be a sideways parabola. So it's either this way or this way, to the right or left. I'm only going to do one of them because it's the same in both cases. So this is kind of hard to understand, so let's break that down to just a part that's going up and a part that's going down. And as you see, the slope here is undefined. And the slope here is also undefined because it's just going up and down. So both of these are undefined, and that's why it's undefined. So this is obviously a minimum, and this is a maximum. Now let's make sure that it follows the same rules as these. Well, it doesn't have anything before it, but it does have every point after it. So after the point for minimum, it goes up, up, and up, but it's going down, but it's still positive slope. So this is a positive. So it goes from something to 0, because or I mean undefined for a critical point, and then positive. Now we do the same thing for max. We have our undefined slope, so it goes undefined, and then any point afterwards kind of goes down, 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 and has a negative slope, so it's negative, so it satisfies our maximum. So in both cases, despite if it's 0 or undefined, it's always going to follow this pattern. Okay, now let's try an example. So let's say we have f of x is equal to x cubed minus 9x squared plus 15x, and it says on the interval from 0 to 4. And we're going to include 0 but not 4. And I'll explain why I'm going to use an interval, because there's different types of maximum and minimums. So first, using our rule, find the derivative, set it equal to 0 or undefined. So that's 3x squared minus 18x plus 15. And a polynomial obviously cannot be undefined, so it's going to be 0. Factor out our 3, so that's x cubed minus 6x plus 5 equals 0. Factor out our quadratic, so that's x minus 1, x minus 5 equals 0. That means x equals 1 or x equals 5 to get it 0. And these points have a specific name. These are called critical points. So these points are going to give us our maximum and minimums. So the first thing we had to do is that if we're given an interval, which we are since I just gave it, then basically we need to check if these critical points are in the interval. Well, 1 is in the interval because it's between 0 and 4. 5 is not, so we cannot consider this. So we have a critical point at 1, and we have two endpoints at 0, and we have an endpoint at 4. Okay, and I'm going to explain the difference in maximum and minimums. There are two types. There is local, and there is global, or you could call it absolute. Doesn't matter which one. So local is anything but endpoints. So going to an example, that means this could be a local, but these two cannot, because these are endpoints and this one is a critical point. So it could be anything but an endpoint, the endpoints. So if this was actually in our interval, x equals 5 was in our interval, then this is going to be a local. This could be a local. This is going to be a local. Okay, now for global, this is either the biggest value, so it's either the biggest maximum, or it's the smallest value, which is the smallest minimum. So what about endpoints? Well, it could be endpoints only if defined. So what that basically means that given our interval, this interval really means from 0 to x to 4. But it includes 4, that's why it's less than or equal to 4, but it cannot equal 0 because that's why it's greater than. So it's going to include 4 as our endpoint. So this endpoint is defined and this one isn't. So if it's an inequality, then it's going to be defined, basically. So less than or equal to or greater than or equal to. And then if it's just less than or it's just greater than, then you cannot, then those are not defined. So basically, this could be a global, but this cannot be a global. Okay, so now that we have that out of the way, how do we determine which one is our maximum or minimums? Well, use this. So endpoints, you don't have to worry about endpoints. Only critical points you have to worry about this. This is where we got this. And then critical point, when we plug it in, we have when we all we had to do is just check points from before and after it. So this is pretty simple actually. If you think about it, we have a parabola. So parabola is something like this. And if we had to choose an x value, usually a parabola is like some kind of thing like this or so, or doesn't matter. It just looks something like this in our graph. Now, if we have a x value at 1, so our graph is something like 1 here, and we have an x value here that's 5 that gets it equal to 0, then the value that's going to be from here is positive, the values below it is negative, and the values right from here is going to become positive. So it goes from positive to negative. So positive to negative, follow this rule. That gives us that 1 is going to be a maximum. So 1 is a max. But what type of max? Well, remember it's a critical point. It's not an endpoint, so it cannot be a. So it's gonna have to be a local. So local max. Well, can it be a global? Well, we don't know that yet because we need to determine if it's the biggest or the smallest. Well, since it's a max, we have to determine specifically if it's the biggest, and we'll do that later. So endpoints determine if it's the biggest or smallest. We gotta plug it into our value. So 0 minus 0 plus 0 is 0. So using f of x. Then plug in 1. So 1 cubed minus 9, 1 squared plus 15 times 1. That is negative 8 plus 15. That's 7. Now you plug in 4. So that is 4 to the power 3, which is 64. 9 times 16, which is negative 144. And 15 times 4, which is 60. So 64 and 60, that's 124, minus 144 is negative 120. Negative 20. So obviously, this is the biggest value. So this local max, it's also a global max. So it could be both at the same time. Now this value is the smallest, and this one is defined. So this is going to be a global min. And this is not anything, so it's nothing. And that's basically how you find max and mins and determine which type they are. In the next video, I'll be covering increasing and decreasing intervals. Thanks for watching, and I'll see you then.